Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at adding and subtracting linear inequalities. Now, I apologize in advance because my voice is a little bit raspy because I'm a little bit sick. Now, we're going to start with a little investigation here. So consider the inequality -6 is less than 9. So is this true? So actually it is, because -6 is a negative number and 9 is a positive number. So yes, indeed, -6 is less than 9. Now, can we add the same number to both sides and this still holds to be true? So, for example, let's say we have -6 is less than 9, and I'm going to add 2 to both sides. So when I do that, I get -4 is less than 11. And yes, this is still true. What about if we choose a negative number to add to both sides? So we have -6 is less than 9. So let's add -2 to both sides. So -6 plus -2 is -8. And then 9 plus -2 is 7. So yes, this is still true because the negative number is still smaller than the positive number. Now, let's consider subtracting the same number from both sides. So again, let's start with our original equation, and that's -6 is less than 9. And let's subtract 1 this time. So we're going to subtract 1 from both sides. -6 minus 1 is -7. 9 minus 1 is 8. And yes, this is still true. So the negative number is still smaller than the positive number. All right, and let's try this one more time. So we have -6 is less than 9. And this time let's subtract -1. Take away -1. So -6 minus -1 is -5. And -5 is less than 10. And yes, that is still true. So, when the same number is added or subtracted from each side of an inequality, the resulting inequality is still true. So therefore, we can still use the zero pairs idea to solve inequalities. So nothing really interesting here. About everything that you've learned about solving equations can also be applied to solving inequalities. However, there is a big difference between solving an equation and solving an inequality. So let's see what happens. So here we have an equation, x plus 4 equals 7. So here we're going to subtract 4 from both sides. And we have x equals 3. So here we can see that there is only one solution. And that solution is 3. All right, now let's solve the inequality. Again, we're going to subtract 4 from both sides. And then we end up with x is greater than 3. Now, x is greater than 3 means that we can find any number where the number is greater than 3. So there are actually an infinite number of solutions. So there are an infinite number of solutions. So any number greater than 3 is a solution. Or we can also say that any number greater than 3 satisfies this inequality. This means that when we solve an inequality, we can have an algebraic answer, or we can also have a graphical answer. So let's take a look at an example. So here we have x minus 1 is less than 3. We're going to add 1 to both sides. And our algebraic solution is x is less than 4. So we know that we have 4 as our starting point, and any number x that is less than 4 will satisfy the solution. So what I'm going to do is I can color in and draw an arrow on all the numbers that are less than 4. And remember that because it's less than, not equal to, we circle the number 4, we draw an arrow pointing to the left. So we can actually check. So if we check with x equals 0, it's always easy to check with x equals 0. We're going to plug 0 back into our original question. So 0 minus 1 is less than 3, and negative 1 is less than 3. So that means that we have colored in the right side of the number line corresponding to our starting point of 4. Let's take a look at another example. So here we have 7x plus 3 less than or equal to 6x minus 2. So we're going to subtract 6x from both sides. And so now we have x. And at the same time, we're going to subtract 3 so we can move our constant numbers to our right side. So now we have less than or equal to negative 2 minus 3 is negative 5. So here we have all the numbers x that are less than or equal to negative 5. So negative 5 is where we start. I'm going to color in our circle at negative 5 because it is also equal to. And we have x is less than, which means all the numbers that are smaller than negative 5. So we're going to draw an arrow pointing again to our left. And to do a check, we can check with x equals negative 6. And when I plug this in, I get 7 times negative 6 plus 3 less than or equal to 6 times negative 6 minus 2. So here I have negative 42 plus 3, and that's going to be negative 39, less than or equal to 6 times negative 6, which is negative 36, minus 2, which is negative 38. And negative 39 is a smaller number than negative 38, so we have colored it in the correct side here. Next, we're going to take a look at 2 special cases. In this first case, it's called all real numbers. So let's see why it's titled like this. So here I have the question, solve the inequality, x is less than x plus 2. So I'm going to subtract x so I can move my variables to my left side. But I notice that when I do that, the variable crosses on the right side, but it also crosses off on the left side. So what I have is that 0 is less than 2. Now this statement is always true. 0 is always less than 2. So since the statement will always be true, the solution is what we say, all real numbers. So the graph is also going to be all the real numbers. Now there's a symbol for this, and we can write this that x belongs to, or such that it belongs to, this capital R with a double bar, which means that it is all the real numbers. And this R is real numbers. So when we graph this on the number line, we're actually going to color in everything because all the numbers will work. So no matter what number that you plug into and substitute in for x into the inequality, the left side will always be smaller than the right side, which makes sense because we're always adding 2 on the right side. So the right side will always be bigger than the left side. The second special case is no solution. So let's take a look at what this means. So this time I'm solving the inequality, x is greater than x plus 2. So again, I'm going to subtract x on both sides. And you'll notice again that this time, again, the x's cross off. But now I have 0 is greater than 2. Now this statement will always be false because 0 is not greater than 2. So the solution to this inequality is what we say the empty set. And the empty set is abbreviated with a 0 with a slash through it. Or sometimes people will call this and say it's called no solution. So the graph for this is none of the numbers. So we're going to leave the graph empty, because none of the numbers satisfies this. That means that when I substitute numbers in for x, x will never be bigger than the right side on the left. The numbers on the left side will never be bigger than the number on the right side, because on the right side we're always adding 2, and we know that the right side will always be bigger. So there isn't any number that we can find for x where this will be true. So just to summarize this, since the answer is no solution, we do not draw a graph on the number line. And that's how you solve inequalities, by adding and subtracting.